Good morning, good afternoon, or good evening, everyone. My name is Max Scholle, and I'm glad to welcome you to this iStructy event titled Tomorrow Cities Engaging Communities in Structural Resilience, Supporting a Provincial Master Plan. This event is organized in collaboration with the Humanitarian and International Development Panel, which I'm privileged to serve on. The HID panel exists to raise awareness to the breadth of context and challenges faced by communities around the world. We do this through knowledge dissemination, outreach, networking, and advocacy, with a particular focus on climate justice issues. As structural engineers, we have a responsibility and opportunity to support communities who are disproportionately affected by natural hazards and climate change. Today's presentation perfectly exemplifies this mission, bringing together technical expertise with community-centered approaches to build a more resilient and equitable future for our built environment. Before we begin, please note that you can ask questions at any time via the Q&A features, and additional resources are available via the link on the platform. Also, to the institution best knowledge, copywriting permission has been provided for all materials shown today, and this broadcast is presented in good faith. Without further ado, our first speaker today is Roberto Gentile, who is a structural chartered engineer and associate professor of catastrophe risk modeling at UCL Department of Risk and Disaster Reduction. Roberto research integrates civil engineering and disaster resilience, advancing risk and loss assessment approaches in developing innovative risk-targeted infrastructure design methodologies. His work has been used by governments, private sector, and practitioners worldwide. During this first section, Roberto will introduce the Tomorrow Cities Decision Support Environment, or TCDSE, a comprehensive framework that combines physics-based hazard modeling with participatory community engagement to enable risk-informed urban decision planning. Our second speaker is Vivek Manandar, who is Consortium Manager at People in Need. Vivek is also a structural engineer and a disaster risk professional with over 12 years of experience in disaster and risk reduction and infrastructure resilience. His expertise lies in structural and earthquake engineering, multi-hazard risk assessment, and climate-sensitive urban planning. Vivek led the Nepal component of the Tomorrow Cities project, coordinating the development and implementation of the TCDSE in Rapti. He will share how this framework was successfully applied to develop a community-driven master plan that has been formally adopted by our provincial authorities. Roberto and Vivek, welcome to you both, and the floor is yours.
Thank you very much. First of all, I hope you can hear me well. Thanks to iStructy for hosting this event and for the opportunity, and thanks for the invitation to Max specifically. In the first part of this presentation, I will talk about the TCDSE, Tomorrow Cities Decision Support Environment, as a general framework, while in the second part, Vivek will look at the applications in Nepal. I have to say that Tomorrow Cities is a large consortium of partners with more than 100 academics, practitioners, and local governments officials all over the world. So Vivek and myself today, we are privileged to represent Tomorrow Cities for this event. And our mission is to reduce disaster risk for the poor in tomorrow's cities. You can see that the three keywords are highlighted here, and we move from the challenge that involves the expansion of world population and, of course, the development of new cities. The Point is that most of this development, especially by the projections considered by 2030, will be built in development countries. But most importantly, 60% of this projected built area is yet to be built. So on the one hand, we have the challenge of facing hazards, especially multiple hazards in these new communities. But on the other hand, we are on time to invert the trend of hazard losses and multi-hazard losses in particular. So with the Tomorrow Cities approach, we try to tackle this problem, and therefore our key aim is to provide an end-to-end decision support system that helps local governments, local provincial units, planning departments to provide risk-informed, people-centered urban planning for communities to be built. And we are looking at the continuous co-development and involvement of all sorts of community members. Our project lasted 5 years. It's just concluded, but there will be a legacy out of it. And it was conceived in a few phases. The first phase related to the design of this framework, and we used a virtual test bed, which is called Tomorrowville, and all the data for this is available online. Then we used some 4 learning cities, Kathmandu, Istanbul, Quito, and Nairobi. With those, we co-developed and we tested, refined, and iterated on the framework until we were happy with the implementation capabilities. And therefore, we generalized the framework, applying it to other cities such as Cox's Bazar and Chattogram in Bangladesh, Nablus in Palestine, and Rapti in Nepal, which is again the topic of this second part of this presentation. Then, our motivations and let's say goals and aims for our decision support environment is that conversely than classic risk assessment approaches, instead of being neutral, we are pro-poor. So we are trying to include the different perspectives of different communities so that we can deliberately be pro-poor. Instead of being top-down, we are a co-developed system, so everything we have developed has involved local partners, local communities, and so forth. Instead of being static, instead of providing a snapshot at a specific moment in time, we have a time-dependent assessment of hazards and their cascades. Instead of being independent, so instead of considering single assets independently, we are systemic, so we consider the interactions between, for example, a person and his or their workplace, their school, their hospital, and so forth. Instead of being completely empirical, we try to be physics-based as much as we can. Before I go into the details, and of course, for every blob in this flowchart here, you will have several papers available, and I would be happy to give you some more details. Let me give you the glimpse of the TCDSC. It starts from the future visioning activities. So the question is to engage communities and asking the question, what is your aspiration for your future community? How do you see your future community in 2030, in 2040? And then we convert these aspirations and maps into urban scenarios. We provide them into GIS environment, and we account for everything that we need in terms of exposure modeling to allow for hazard and impact modeling. We project hazard scenarios and we subject those urban scenarios, those future communities to different hazards, and we compute impact. And I will tell you what I mean by impact in a second. Then we go back to the community with the results, and we do what we call risk agreement, where we collect all the aspirations and perspectives of the community in different metrics of impact. And then once we are happy, after iterating over the future visions because of what the risk agreement has provided, we implement the results into the real life. And this is what we back will tell you. Future visioning, it looks like a diverse set of community members, including residents, government officials, researchers, NGO members, community champions, and so forth. And most importantly, they are deaggregated into socially coherent social groups, in the sense that this will allow to minimize the power imbalances in between the different groups. Let's say, for example, we have a group of women, we have a group of children, we have a group of business people, we have a group of elderly, and so forth. They operate in workshops separately, and then they join at the end of most workshops, so that everyone is allowed to express their voice. The mapping workshop, as I said, how do you envision the future of your city or your community, ends with hand-drawn maps of the future community and a set of aspirations that the different groups allow for the community. So, for example, an aspiration could be to have a better development and management of green spaces. This is a common option. Therefore, every group has an urban scenario that is at this stage based on a hand-drawn map. We convert that with some back-end work. We convert that with a group of specific experts in GIS and everything that we need to account for a digitization of these plans. We account for the local urban planning law. We account for local codes for structural design, for example, and similar. And we then go back to the community to verify that our work is still matching their aspirations. In terms of exposure data structure, we have developed a specific, let's say, pipeline that, unlike common approaches that stop at the building level, or I should say the asset level, we also include household attributes and individual attributes. So there is this, if you want, a relational database for which every land use is characterized by its attributes. So, for example, the land use type, if it's a residential, agricultural, and so forth, its density. The buildings, they are computed based on future population projections, and the buildings have their own attributes consistent with the local census and so forth. So we know the occupancy, the height, the material of the buildings. All these buildings are, of course, projected. They are a simulation. And then we simulate households inside each building according to their poverty status, the number of individuals in each household, which school they are attached to, which hospital or which religious building they are attached to, and so forth, workplace. Individual attributes are modeled and synthetically, let's say, simulated, considering their gender, age, and education attainment. And this is all consistent with the available information in the census or with expert judgment if needed by social science expertise in the areas. As I said, we do this dynamically, so we have different snapshots of the projected population and therefore buildings and therefore assets in general in the cities at different timestamps. And we do that with specific modeling approaches that I'm happy to explain in the questions if you want. Then we go for multi-hazard modeling over the urban scenarios. Here I'm showing 3 examples, but I should emphasize that every community has some specificities, and therefore it will be tailored. The approach will be tailored to consider the hazards that are more relevant for the community that we are involved with. As I said, we are physics-based as much as possible, so you can see some physics-based modeling of the case study on the right. You can see that we have modeled every fold, and this is a community in Nepal. And we also consider different hazards. As I said, this is another example in terms of flood, where we did the hydrograph approach for the same community. But most importantly, look at this interaction in the GIF. Now, there is a flood and a rainfall event that builds up the flow in this river. The river is pushing against an earth dam that then collapses and creates a debris flow downstream, sorry. And therefore we are able to account for this kind of cascading or interacting in general events. This is for the hazard. For the vulnerability, we start from the physical vulnerability of the assets. So let's consider buildings. We classify them according to their properties, exposure properties, and therefore for each class we attach a fragility and vulnerability model that is related to every hazard that we care about. On the left, you can see some fragility functions for earthquakes. On the right, you can see some vulnerability functions for flood for a specific building. This will allow to account for the physical impact in terms of damage states. So you can see different damage states on the left for earthquakes, slide to complete, or economic losses that is commonly done for floods. But we wanted to go further because those metrics are not well suited for a pro-poor approach or a human-centric approach, I should say. So we wanted to go beyond. So beyond damage, we attached some mechanism that transform damage and economic losses into other impact metrics. So for example, casualties and injuries, human displacement or unemployment, poverty metrics, school functionality, healthcare functionality, water and electricity disruptions or connectivity of some of the networks in the system with the specific people in the simulation. And we account for all of this into a computational engine, which is open access. I would strongly suggest you to scan the QR code so you can look at our web app and use it if you need. How does it work? We embedded all our risk modeling approach into a computational engine that accounts for inputs like land use, buildings, roads, bridges, hospitals, and power and water networks. That's the maximum we can do. It accounts for some specific policies that are connected with the aspirations of the community members, and it accounts for some hazard scenarios. We use the computational engine to compute the impact metrics that I've shown you, but on top of that, we also account for, and now we are going back to the communities because our backend work has somehow completed, and we are going back to the communities by considering which impact metrics are more important for them. And we realize that different community groups will have different priorities over the impact metrics. Some groups will have educational continuity as their most important metric to reduce. Some others would have, I don't know, job continuity as the most important one, and so forth. So we have devised a serious game approach that allows us to capture for each community group their relative priorities on the metrics. So we can weight the metrics and we can provide a more refined and human-centric vision of the risk. How it works is the following. The backend work will use the computational engine to compute the objective evaluations of impact, as we said before. The serious game will provide us the priority, so the relative importance of the different impact metrics, and it will allow us to weight the impact metrics and combine the objective computation of risk with the subjective visions of the communities, so that we can understand and provide an understanding of risk that is community centric. Finally, we go back to, in the same occasion, we go back to the community with our computed impacts for the different urban scenarios, one per community group, under the effect, let's say, the impact of the different hazard scenarios that we consider for a community. And here we use a tool that is very interactive, because we realize that risk communication here is an extremely challenging task, because we are trying to communicate extremely complicated risk results for different community members with different levels of education or expertise. So we devised this tool that allows us to filter buildings in the scenario that we have, show the damage state, show the different impact metrics with those speedometers that you can see below, and those speedometers would change depending on the zoom that you provide in the web app. And this allows us to provide a workshop where the community members in the risk agreement workshop provide revisions to the urban scenario based on their understanding of risk and their subjective priorities. We want to go beyond the model because we understand there are assumptions, and therefore we cannot model everything. So the second part of the risk agreement workshop looks at the challenges that a community would face by trying to implement the modifications of the urban scenarios that they have identified. And this is a completely social science-based approach. Now, we can implement those changes into the future visioning and reiterate until we are happy. And then when the community members are happy with the calculation and the derivation of the urban scenarios, we move on to the implementation pathways, where we try to use these results in total or in part to, let's say, influence policy, which is going to be the VBEC's contribution in this presentation. 3 takeaways before VBEC. Number 1, we have the TCDSC, which is an end-to-end stakeholder-driven process for modeling, characterizing, and assessing risk associated with future natural hazards. The strengths of this approach are referring to the ability to capture tomorrow's risk, the ability to account for physical and social network interdependencies, and being completely participatory and co-developed, and embed the community perspectives in risk measurements. The impact is demonstrated in 10 cities worldwide, all in the development communities. And one of these impacts will be now discussed by Vivek for the city of Rapti in Nepal. Thank you very much.
First of all, I would like to thank iStructE and the organizers for giving us this opportunity to present. Having completed my master's degree from University College London, I always feel good and happy presenting in front of the UK engineering fraternity as well. So thanking again the organizers. So my presentation is going to be, as Rob pointed out, the implementation side of Tomorrow's Cities, where we helped develop a multi-hazard, risk resilient and inclusive and participatorily developed master plan for the city of Rapti, which is the capital city of one of the 7 provinces of Nepal. And in the later part of my presentation, I'm also going to touch upon a case study where we helped an ancient town in Nepal that lies very near to Kathmandu enhance its earthquake resilience by developing building catalogs. So as Rob mentioned in his presentation, we followed the TCDSE quite meticulously, starting from the future visioning exercise at Rapti. So, okay, I'm not sure if you can see my slides here because I'm not able to
Yes.
see slide number 3. Okay,
Yes, we can see your slides.
thanks, Olga. Okay, so in this stage of future visioning, we brought together the community and sat down with them and enabled them to draw their visions out onto paper. Now you can see 6 maps here because we had 6 disaggregated groups. And we had 6 maps with hand-drawn visions of what the community want to see their city like many years into the future. So one of the groups we had was the indigenous Tharu community, which is indigenous to the region. So other communities included squatter settlers and people from other ethnicities, and one of the groups even included the policymakers and planners. So I'm focusing right now on group number 1, which was the indigenous Tharu. So as you can see in the slide, there is a very big, bright ring road, as we call it here in Nepal, surrounding the valley. The river is running across the center of the valley, and you can see different demarcations of land uses like agricultural zones, residential spaces, landfill sites, and everything. So this was what the people draw based on the imagination and discussion facilitated by our team on what they wanted their city to look like. And then, as Rob also mentioned, we went on to the next stage where we transformed these plans into these GIS-based visioning scenarios, which adhere to these existing norms and standards. And this job was done by a team led by urban planners, engineers, and social scientists to transforming these rough visions into somewhat of a realistic scenarios. And then what we did is we went back to the community to validate these digitized versions of these plans. So here I'm presenting you one of the plans from the squatter settlers group, where you can see provisions that were requested later on, other than from the future visioning workshop, where you can see the mentions of embankments, separate areas that's favorable for squatter settlers. And interestingly, you also see these visions for these Tharu homestays or museums that exhibit the relics of the indigenous culture. And you also see a mention of vulture conservation centers as well. And you can also see on your far right the provisions for these large infrastructure projects like cable cars connecting these town centers with touristic hubs and destinations. So we had these diverse views again coming in our validation workshop, which we then again incorporated in our digitized versions that you can see on the right. And while parallelly, other set of technicians, as Rob already mentioned, was working on generating these exposure data, which not only factored in the physical infrastructure like buildings, but also the human side of things like age distribution, gender, and everything. And we also incorporated different typologies of infrastructure. For example, here I'm exhibiting the example of residential buildings. So we incorporated all the typologies that could be, that were envisioned by the community. For example, it started from the Tharu traditional buildings all the way to these modern reinforced concrete structures. And we incorporated the vulnerability and fragility functions for all of these structures as well. For some, it was very easy because these are some were very modern reinforced concrete buildings for which we have an abundant data set of functions. While for some, like the Tharu traditional buildings, we had to improvise while defining these functions that related intensities with probabilities of damage, for example. And while at the same time, the hazard modelers were also working on modeling hazards like earthquakes, floods, and landslides in different scenarios. And then after combining all of these data, we went back to the community to now have an informed decision on observing what the impacts of these different hazards are going to have in their individual visions. So we had 6 groups. So while going back to the community, we took with us 6 projectors and 6 screens and then discussed with them, okay, these are the impacts of different hazards that are going to have in the visions that you helped create. So this is the same dashboard that Rob showed us. So here you can see that there's one scenario that is being discussed with one group, and this allows zooming in and out like we just saw, and we can see the figures on the bottom change depending on what is being selected. So I'm going to present here 2 examples on how we ran these discussions with the community. So for example, here we presented a scenario, a polygon. We selected one, or let the community select it themselves and see where the high impact polygons or high impact pockets of villages were situated. And we asked the question, and we facilitated them to ask the questions themselves among themselves as well on why the impact was so high in those particular polygons. And then they later explored themselves that maybe it's because there's a high density of residential buildings with very weak structural integrity, for example, brick in mud mortar. And conversely, in some other polygons, they also observed themselves that maybe this polygon has lower impacts, for example, in the form of lower casualties because there is a high density of reinforced concrete structures that is also high code. So these are just 2 of the simplest examples that I'm showing you here, how we ran these discussions. Again, as Rob said, this was very meticulously planned because we're dealing with very complicated engineering terms. So we even went down to the detail of differentiating and communicating with the community on the difference between magnitudes and intensities. And to our surprise as well, they were very open to understanding those concepts. And by the use of this dashboard, they were also very conveniently understood by the communities themselves, because especially because we use these graphics and colors and filtering mechanisms in this dashboard as well. So here's another example of the flood scenario that we used as well, again in the same community. And an interesting observation was that they noticed, they understood that intensity doesn't always equal high impact. So it was discovered, for example, where there was low inundation but high impact because those regions were highly and densely populated. So this was another understanding that the community took away from our exercises. Now, after all of those understandings, we collected this matrix of different policy suggestions from all of those 6 communities, and we consolidated them and then took those suggestions, working together with the Provincial Infrastructure Development Authority, into incorporating them into the master plan. So here I'm presenting you one of the instances on how we used the impact data that we observed, and also the policy suggestions that came from the community, and also the policy suggestions that came from the authorities and planners in making changes to the master plan. For example, here you can see we adjusted the setback lengths of these different land use zones from the edges of the river. So this is just one of those examples that we we incorporate it in the master plan itself. And the other changes that we made is, for example, the alignment of the ring road that you saw in the beginning of the drawing, in avoiding these high intensity areas in terms of flooding. We adjusted these different infrastructures like animal shelters and the Tadu homestays. And we also added a signature bridge, which was proposed by the Infrastructure Development Authority and very much accepted by the community as well. So the location of this bridge was also key in the decision for the location was also as a result of our study, and other infrastructures and locations like landfill sites and these industrial areas as well. So another important thing that was significant was the acceptance of the master plan and the commitment, rather, with a declaration signed among the key stakeholders in the province at an event as well. And we also got the endorsement from the National Disaster Risk Reduction and Management Authority from the central level, and also the key stakeholders at the province in the form of the Development Authority Chief and also the Chief Secretary of the province. And we're also very happy to share that we ran these parallel capacity strengthening program along with the implementation, where we had these dedicated modules in parallel of the 4 steps of implementation. And we developed these comprehensive workbooks for these 4 modules, and also deployed this online training, not only in Rapti, but across other international cities and tomorrow cities with 400 graduates of the program. And then we also had many community engagement and awareness events along the implementation at Rapti. So this is actually the last slide for the Rapti case. So this is how we implemented this co-creation of a multi-hazard disaster risk informed master plan through an extremely inclusive and participatory process, working with not only the development authority, but also the community from start to finish. So moving on to the next portion of my presentation, as I earlier mentioned. So as part of the same project, Rob mentioned one of the learning cities was Kathmandu. So we work while working in Kathmandu, we work at Kokana, which lies at the southern edge of the city. So while going through all the steps at Kokana, we had a special task, a special request from the city in supporting earthquake resilience while staying true to its traditional cultural heritage and roots. So Kokana is an ancient city with its own cultural heritage and its special cultural values. So I put this screenshot here because if you squint your eyes, it looks like a screenshot from a strategy game. But this is this is the main temple of Kokana, and again signifying the very unique culture that the city of Kokana has. So as a special request from the community of Kokana, and especially the ward chair himself, he requested us to develop these model building guidelines and catalogs for residential buildings at Kokana. As you can see here, this is actually the ward chief's office, and you can see this very traditional structural elements with thick load-bearing walls. So we held these meetings, multiple meetings with the community and the ward chair himself, in how we can develop these model building catalogs that were both earthquake resistant, but then retain their cultural aesthetics and architecture. So this was the model building catalog that we developed, which had reinforced concrete elements and structural load-bearing elements, but had these traditional architecture on the outside. So structurally, as you can see here, these are your very typical regularly shaped reinforced concrete building plans. So we employed our best engineers and architects in the country, which designed these code-compliant RC residential buildings that was compliant to the Nepal National Building Code NBC 105, which is the seismic design building code of Nepal. But the outlook, the outside was adhering to the traditional norms and values of the locality. Here you can see these very beautiful traditional wooden carved windows. And actually on the right, you can see the ward chair's home itself, which also has the same type of window as well. So I would now like to discuss more on this particular home that the ward chair has. So this goes a step further from our catalog, where the RC beams and columns are, the beams and columns are reinforced concrete, but the slab in itself is still traditional. So it is a flexible diaphragm. It is like a hybrid RC building where the slab is not a reinforced concrete. So the ward chair himself hired technicians and designed this building using these modern softwares and modern expertise, while still staying true to at least the slab of the building. So this is like a hybrid structure where the slab is compacted clay overlain with bits and pieces of wood like the traditional houses would have, and then overlain with your clay tiles. And the whole slab is then supported by wooden joists running in both directions. So you can also see here on the roof section the traditional clays interlocking with themselves. So this was a unique building that the ward chair had, and what the community also strives to achieve in the future, and a step further would be again achieving a full architectural and a structural adherence to the traditional construction, where the walls themselves would even be load bearing in nature. So coming back to our catalog, so since the ward chair requested that we had to do this in scale, and we had to also maintain economy and replicability, we went with the structural system being fully reinforced concrete, even at the slab level, and just the outside then catering to the architectural norms. So this is your typical cross section of your reinforced concrete building, with your typical isolated footings with two tie beams at two different levels. That is the plinth beam and foundation beam at the bottom. And it also incorporates these other seismic resistant elements that enhances the seismic performance of the reinforced concrete buildings, which is also included in the National Building Code. For example, these two bands, horizontal bands, that prevents the outer plane failure of these infill walls provided at two different levels. So this is again a picture from our catalog with the RC structural elements, complete with the outer facade that adheres to the cultural norms. And then we went on to make three versions of this in order to cater different land sizes, because in, not only at Kokana, but in Kathmandu as a whole itself, land is very scarce. So we had a request that we make three different catalogs for three different cases. So three different models and three different catalogs were handed over to the ward. So this is for the 4, 5, and 6 ANA land. So ANA is actually a unit of measurement that's equivalent to 345 square feet. So this is for 4 ANAs, 5, and 6 ANA lands. And we also had an event where we handed over these catalogs to the ward chair of Kokana, and also at the presence of the deputy mayor of the city, which Kokana is a part of. And here you can see our project team participating in the handover ceremony as well. So I would like to thank everyone for your kind attention. I hope you enjoyed it. And at last, I would like to acknowledge the Tomorrow Cities Nepal team. Although, as Rob mentioned, we are a very big team, a very, very big consortia. And I would like to take this time especially mentioning Tribhuvan University Institute of Engineering, the National Society for Earthquake Technology Nepal, where I used to work during my tenure at Tomorrow Cities, National Development Research Institute Nepal, CIAS, and Practical Action for their contribution. Thank you very much.
Thank you very much, both. That was very, very interesting and insightful presentation. Yeah, I think it's always good to hear about, those new ways of maybe approaching and thinking about hazards, and how, as engineer, maybe now there is a drive, especially with climate change, about us not considering every single hazard in silo, but having more like an integrated approach. And how does that work when all those hazards basically combine with each other over time and also spatially? So yeah, we're gonna kick the Q&A. We have a couple of questions that have come through, so I'm gonna bring them to you. I think there is probably a first one here, which is probably for, I guess, both of you, but maybe Robert, you can answer it, which is about how did you actually define the flood and earthquake scenario models? What was the approach? What were the typical features of the model? Whether it's like literality based, or did you actually come up with something more based on fundamental principles? So yeah, how were they actually defined?
Thank you very much for this question. Now, while as soon as I finish answering, I will also pop up in the chat the link to a paper that will give you some details of this, specifically for the city of Rapti. But referring to the flood, we had number one, we had so first of all, we account for the climate change projections. That's the standard case. We have the no climate change signature case, and then we account for one of the pathways or scenarios, if you want. So we have, as a matter of fact, events of different intensity in terms of the, let's say, the scale of the rainfall. Then, once we have identified the, the rainfall that we need to model, we account for the, let's say, um, I would say, to be specific, we have a two-dimensional slash monodimensional hydraulic model that interestingly we have carried out twice, once by not including the buildings into the DEM, so the turbulence around the buildings was neglected. And in another case, we also accounted for, we embedded the buildings into the DEM, which of course it's tricky to do because the buildings are hypothetical. So
So
it's
maybe for the
impossible.
audience, DEM is digital elevation model.
Yes,
Yeah.
digital elevation model. Sorry for the for the acronym there. If you want the details about which software we used, which parameters we used, what is the return period of the different scenarios that we used, I will now pop up the link to the chat, but I believe I captured the important points there. It's a completely physics-based model, accounts for climate change, and there is a community of local and international experts that talk together to define what are the scenarios that are going to be tested for the city.
Yeah, thank you. Another question maybe here for Vivek this time. When you mentioned the different typology of building which have been considered, from very traditional to maybe more like well documented, like RC buildings, how did you actually came about, defining or evaluating the fragility function for, I mean, both like earthquake in that instance and also flood?
For earthquakes, for fragility functions, we were lucky enough that we had indigenous curves for brick and mud, brick and cement buildings, and most of the buildings that you saw in the slides. But for the traditional Taru buildings, we had to improvise, taking these weak in terms of earthquake resistance. So we took some coefficients and then modified the curves for the Taru buildings. As for the flood, we used most of it from the Joint Research Center, JRC curves, with some modifications because they only cater to lower story buildings. So we use those curves to our scenario to match those vulnerability curves in our cases.
Okay, yeah, thank you.
Max, if I can quickly add, the general approach is we use global models when needed. So, for example, the JRC.
Yeah,
So, to just mention the general approach, we try to go for global models. Then we try to look at specific studies, like, for example, the fragility functions that we have adopted are the result of the PhD thesis of one of the members in the TCDSC, and if not, we develop them. We provide the numerical modeling of the buildings, and we provide the vulnerability or the fragility, depending on what we need.
yeah. There's just another question that came through, which we probably have the time to answer with the kind of 3 minutes we have left. There is a question about basically that kind of participatory approach, and how did the community actually perceived, those questions such as insurance or emergency centers, where they should be located, and also on basically the definition of the risk in terms of like catastrophe intensity, frequency. How that's been perceived by the local community.
Mhm. So I guess that question is for me.
Yeah,
Yes. Yes, so as we also mentioned, we had these meticulous rounds of discussions among the team ourselves before going to the community, so that we had the best language and the best approach and the best methodology while we were approaching the community with these very complex terminologies. So, uh, again, as you said, regarding these frequencies and magnitude and intensities, we had meticulously prepared these materials for the community to understand these concepts, and that is how we were able to draw in their feedback and then incorporate it into our planning process. I think that's what you asked, right? Was I able to
yeah,
answer
yeah.
it correctly?
Well, I think that kind of also raised the question about, because you have that kind of objective side of things where you try to build a model to basically try to be objective, and then you have that participatory approach when inherently is a bit subjective. And I think that question was about how what are the challenges in terms of like trying to combine the two, both in terms of how do you communicate the risk to the community, but also
Mhm.
how the risk will actually perceive those risks, and how the whole entanglement on of like the risk landscape in their own in their own community. um yeah, so I think we are getting to the end. We won't have the time to take any more questions, but if you have any questions you would like to ask to the speakers, please keep posting, because we will actually come back to you with an answer post presentation. So yeah, but don't be shy. If you have anything you would like to ask, please keep on posting on the chat. So yeah, that's basically conclude this lecture. So again, Roberto and Vivek, thank you very much for your presentation. I think it was very insightful and an engaging conversation.
Thank
I
you.
need
Thank you very
to
much.
open this.
Thank you so much again for the invitation. I just wanted to quickly mention that on this last question, there is the one episode of our podcast that refers to this. If anybody is interested, I can share the links.
Now we can probably share the link as part of the resources. Yeah, that would be a good idea. So yeah, just for those who are interested, so obviously that presentation has been recorded. It will be available in a few weeks from the iStruct YouTube channel. If you want to know more about the HID panel's activity, you can follow us on your preferred social media platform, or check our iStruct webpage, where you can also find the details for all our upcoming events. Speaking about events, there is a couple of very good ones that are coming up with the iStruct. So no later than this Friday, we have the Young Engineer Conference, followed next week by the Future of Design Standards. After the summer break in September, we have quite a busy schedule with the financial fundamentals, the foundation design for small practitioner, and we're concluding the month with our annual academics conference. Before we finish, I would like to remind you about the iStructive Benevolent Fund, which provides financial support and practical support as well to members and their family in times of need. So if you want to, you can make a donation by scanning the QR code provided on this slide. So this concludes this presentation. Thank you all very much for attending, and thank you again, Vivek and Roberto, for very, very good presentation. I hope today's discussion has given you new perspective on community-centered risk reduction and how it can support our day-to-day practice as structural engineers. Thank you for watching, and I look forward to seeing you at future iStructT or HID events.